he had developed a product that we had actually looked at carrying at one time. And this was a beef collagen derived from Argentinian beef. And what he had found in his experience with athletes was that when they were getting loss of cartilage from playing football, a lot of wear and tear, and in the United States, American football players, most of them need knee replacements by the age of 50. Okay, so this is a significant problem. So what he was finding was that if they supplemented with collagen protein over a period of, let's say, 6-9 months, most of this cartilage would come back. Now, these are with people that are in their 20s or early 30s. But what does somebody that's a little bit older do? How can we speed up this process? So we wanted to take a look at this. At about the same time, it was within a few years after that, we were on a cruise in the Mediterranean. I think it was our 6-year anniversary cruise. And a doctor from Switzerland came on board the cruise ship. And, we plan these events out months in advance. And especially when we're on a cruise ship, since we're only there with our members for a couple of days, it's like every minute that we have is planned out. And he approached me and he said, "I've got to talk to you about something that I found out about your patches." And I said, "I'm sorry, my schedule is full and I don't have time to meet with you." He said, "I am an orthopedic surgeon from Switzerland. I flew here to meet with you, and I have found a way to regrow cartilage with your patches." And I said, "When do you want to meet?" So he told me, so this case was, he had a woman that was in her 70s, and she was bone on bone. And we were just about this time releasing the Eon patch. And actually, we hadn't even released the Eon patch. We only had put out test samples to maybe about 500 people or so in the company. And he had gotten some of these test samples of the Eon patch. He didn't really know anything about it. And he had read an article that was in a research journal that was talking about how glutathione could regenerate cartilage. So this woman did not want to go through surgery, and he was concerned that if she went through a knee replacement, she might have significant complications. And he said, "What the heck? I'll try applying a glutathione patch to the knee and see what happens." So we put a glutathione patch on the outside of the knee, and that bioelectrically where we place it. Now, he had a package of Eon patches, and back then we called them the X15, because that was the 15th patch that I had developed. And so we did this as part of our marketing to develop some mystery around this, right? So it's called the X15. And he said, "What the heck? I'll just apply an X15 on the inside of the knee, and let's see what happens." So a month later, she had regrown enough cartilage that she didn't need the knee replacement. She was out of pain, and she was walking, and she was doing okay. So we started to really, think about this phenomena, and we started to get asking questions, from people over the years about what to do. So what we began to recommend was this kind of combining the best of everything, and recognizing that collagen protein is the raw material that is going to be used to make the cartilage. And we knew from the experience of Dr. Friedlander that just using collagen protein over a 6 to 9 month period could restore collagen, at least in people that are a little bit younger. So that's why we recommend it. So clinically, he's recommending 10 grams per day. So on the bone broth, which is one potential source of collagen, typical dose could be 10 grams. If you want to take 20 grams, that would be okay.
It's like a cup of bone broth,
Yeah,
like a soup or what?
Broth. And there's other sources of collagen, right? There's other sources of collagen powder. But you would take, let's say, a scoop of this, you get about 10 grams or more, you put it in a cup, you add hot water,
Yeah.
and then you drink it, and it's a nice beverage. Right? It's like having a warm soup.
How about the C vitamins?
Okay, I'm getting to that.
Yeah, oh, sorry.
So, no, that's okay. So the next thing is we look at what triggers regeneration in the body. And there's a few things that trigger regeneration. And this kind of fits into, our overall conversation anyway, so I'm gonna take us down another road, right? Because I think you'll enjoy it, and I like to talk about it because it's Sunday. I get to choose. Just kidding. So, no, but I really think you'll find this interesting. So, how does the body go about and repair? And I'm going to tell you something that was discovered right in San Diego. And I was very fortunate to have met the doctor that discovered this. And he's actually the chairman of the FDA for regenerative medicine. He's a great guy. He's very well known. His name is Dr. Evan Snyder. And what he discovered was how a stem cell repairs damaged tissue. And it makes complete sense when you hear it. At first, you say, well, wait a minute, how's that working? But then it makes complete sense. So when you have an injury, it generates inflammation. So inflammation is a good thing, because it's there to tear down the damaged tissue. So when we have tissue that's damaged and it's no longer functional, our body has to have a way. I'm not finished. You have to have a way to get rid of it, and that's the reason why the inflammation is there, to get rid of it, so we can build new tissue. If the inflammation stays around, that's the problem, right? Because now it can go on damaging tissue that's healthy. So we only want it to get rid of the damaged tissue. So what happens is you elevate these chemicals called cytokines, inflammatory cytokines. And the stem cells have antennae. This is actually an electromagnetic effect, although it's recognized as being a biochemical effect. They don't look like that. So they got these little antennae, and all of a sudden they get this chemical signal that there's an inflammatory cytokine. So these stem cells, they hunt for it until they get to the site. Now there's a paradox here, because once the stem cell gets to that site, it dies. So you can, and this is one of the problems in stem cell medicine, is that you can inject a colony of several million stem cells, 2 million stem cells, into an injury site, and an hour later, maybe you only have 200,000 or 100,000 stem cells, because the inflammation killed them. But when they get to that site, the stem cell releases a growth factor. Okay, and there's many different types of growth factors. There's IGF-1, IGF-2, VEGF, there's a whole bunch of different growth factors. So it releases it over to that site and initiates repair. So if we understand how can we trigger regeneration, we look at the chemistry. And ascorbic acid is involved in conversion of proteins over to other proteins. So in other words, we can take the collagen and we can convert it to another protein. We've got to have the growth factors there from the stem cells, and this is why it's more difficult to repair damaged tissue as we age, because the stem cells age at the same rate that we do. So one of the companies that I've met with that's interested in a technology that I developed is what they do is they take very young stem cells that, believe it or not, today are being thrown in the trash. So when a woman gives birth, they take the umbilical cord that's loaded with mesenchymal stem cells and they throw it away. And instead, there's no ethical issues with this. Instead, this company will take those stem cells, they'll harvest them, increase the number, and then you inject them into healthy tissue, and then they do their magic. That's a just really simplified explanation. But in any case, this is why it's difficult for people that are older to repair, because the stem cells are aging, and when the stem cells age, they don't repair as efficiently. So we've got to kind of help the body along. So one way to do that is, first, we make sure the body has the raw materials that it needs to regenerate the cartilage, and that's collagen protein. Second thing is we want to make sure we have the raw material there to help trigger regeneration and convert the collagen over to cartilage, and that's vitamin C. What recycles And what's another trigger, and what we recycle is vitamin C,